Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, suppose that the monthly revenue in thousands of dollars for the sale of X 100 units of an electronic item is given by the function r at x equals 40x squared e to the power negative 0.4x plus 30, where the maximum capacity of the plant is 800 units. Determine the number of units to produce in order to maximize revenue. So we are given the revenue function for an electronic item, and we need to find the x values, which represents the 100 units of an electronic item that will maximize revenue. So the first step is to write the revenue function and find out its domain. Now x represents the number of hundreds of units of an electronic item. So we know that x cannot be a negative number, so therefore the minimum value for x is 0. And as per the problem, the maximum capacity of the plant or the factory is 800 units. Now since x is in 100 units, so that means the maximum value for x is 8. So this should be the domain of this revenue function. Now we have to find the x value that gives us the maximum value for revenue in this domain. So the first step is to find the derivative of this revenue function and then set the derivative equal to 0 to find the x values at which the tangent is horizontal. Because for maximum revenue, we have to find the x values in this domain where the graph forms peak in the domain. So let's start by finding the derivative of this revenue function. Now the first term in this revenue function is made up of a polynomial term 40x squared and the exponential function e to the power negative 0.4x. Now this exponential function has a base e. And since these two functions are being multiplied, we'll have to use product rule to find the derivative. So as per the product rule, we should start with the derivative of the first function. So in the first function, 40 is the coefficient, so it will stay as it is. And as per power rule, the derivative of x squared is 2x times the second function plus the first function times the derivative of the second function. So for the exponential function, the derivative will be the e term itself times the derivative of the exponent. Now the exponent is negative 0.4x, and in this exponent negative 0.4 is the coefficient, so it will stay as it is, and the derivative of x is 1 plus, now 30 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So 40 times 2x is 80x. Now in the second part, negative 0.4 times 1 is negative 0.4, and we can multiply negative 0.4 by 40. So I got 16. So it will become negative 16 x squared times the e to the power negative 0.4x, and the plus 0 goes away. Now we can set this derivative equal to 0 because we have to find the x values at which the tangent is horizontal. Now we have to solve this equation, so we can do common factoring. So we can factor out 16x and then e to the power negative 0.4x from both terms. So the common factor is and we are left with so this is what's left in the parentheses. Now we can solve this equation. So we get three cases. So the first case is, so now we can solve for x by dividing both sides by 16. The 16s on the left side get cancelled out. So we get x equals 0. Now we can analyze the second case. Now there is no x value that will make this e term equal to 0. So we get no solution from this case. Now we can analyze the third case. So we can isolate x by subtracting 5 from both sides. So the negatives get cancelled out. So we get x equals 5. Now this x value lies in the domain we found. That means this is a valid value of x. So is the first solution we got, x equals 0. Now we have to find the x value which will maximize revenue. So we have to find the revenue value for x value 0, which is one of the solutions we got, and it is also the lower limit of the domain, and then x equals 5, and then x equals 8. So let's start with x equals 0. So we'll sub in x as 0 in the given revenue function. Now 40 times 0 square will be 0, and that will make the whole term 0. So we are left with just 30. So that means at x equals 0, the revenue is $30,000 because the revenue in thousands of dollars. So that's why we have to multiply 30 by 1000 to get the actual revenue in dollars. Now we can use the x value 5. First we can multiply 40 by 5 square, which is equal to 1000. Now the exponent of e is negative 0.4 times 5, which will become negative 2. Now we can simplify this expression. So 1000 times e to the power negative 2 and then plus 30. So I got 165.34. So I'm rounding the answer to 2 decimal places. So the revenue in dollars will be 165.34 times 1000, and that is $165,340. Now we can use the x value equal to 8. So we can evaluate 40 times 8 squared, which is 2560, and then e to the power negative 3.2. Now we can multiply 2560 by e to the power negative 3.2 and then plus 30. So I got 134.35. So I'm rounding the answer to 2 decimal places. So in dollars, the revenue will be 134,350. So we have to multiply these R values by 1000 because the function represents revenue in thousands of dollars. So we can see that the maximum revenue was obtained for x equals 5. So that means the number of units that maximize revenue is 500 because the unit of x is hundreds of units of an electronic item. So our conclusion will be 500. So 500 units maximize revenue. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.